Hello and welcome to today's class. We are going to look at logarithms of numbers less than 1. In the previous class, we looked at logarithms of numbers greater than 1. So we are going to dive into the first example, and that's going to be finding the logarithm of 0.57. So as you already know, the first thing you want to do is write the number in its standard form, which usually takes the format a times 10 raised to n, where we say that a is supposed to be between 1 and 10, 10 not being included. All right, so basically we are going to move this decimal point to the right, and when we do that, we're going to have 5.7 times 10. So the number of times we moved that decimal point is what's going to form the value of n, and also the direction, because we moved it to the right, it's going to be -1. We moved it to the right only once. So for us to find the characteristic, remember when you're finding logarithms, we have characteristics and we have mantissa of whatever forms the log of a number. And so -1 here, which is the power of 10, is going to form our characteristic. And of course, being a negative, we won't write it as -1. We will write it as bar 1. All right, we will write it as bar 1. So anytime you see bar 1 or any number with a negative sign on top of it, basically it means that it's supposed to be read as bar 1, and it's also an indication to a logarithm of a number that is less than 1. So instead of writing -1, we will write bar 1 point. And so for the number 5.7, of course, remember, of course, that is the mantissa. We will read it directly from the logarithm table. All right, so we are going to go to the x column, all right, where we are having 5, to the x column, of course, and find 5.7 from the table directly. And so you are going to notice that that's going to give you, if you go to 5.7, of course, in the logarithm table, under the column of 0 in the midsection, we are going to get that the logarithm of 5.7 is 7.559. And so therefore this here becomes the logarithm of 0.57. So let us do another example, of course, and see what we get. All right, so this is A, and for B, we are going to pick the number 0.00063. So anytime you're dealing with anytime you're dealing with numbers that are less than 1, expect that the logarithms are going to have bar numbers. All right, so basically the first thing we're going to do here is write this number in its standard form, and note the standard form of this number should take the form a times 10 raised to n, and we are saying that a is supposed to be between 1 and 10, where 10 is not included in that inequality. So basically we are going to move this decimal point to the right up until we achieve that range of 1 and 10. And so when you move it, you're going to have that a is going to be 6.3 times 10. So the number of times we moved the decimal point to get 6.3 is what's going to form our nth value, of course. And of course, that's also going to be a negative number. Why? Because we are moving the decimal point to the right. So the number of times I moved it is 1, 2, 3, 4. So we are going to have our 10 here raised to -4. That therefore means that the characteristic of this particular logarithm is going to be bar 4. So we do not write -4. Instead, we write bar 4, all right, for logarithms. Of course, point. So for us to find the mantissa, that is a number that comes after the decimal point, we will read it directly from the logarithm table. And basically, we are going to find 6.3 from the x column of the logarithm table. And so when you go down the x column, finding 6.3, under the midsection where we are having 0, you're going to find that the logarithm of 6.3 is 7.9 4.93. And so therefore this here is the logarithm of 0.00063. So the logarithm there is bar 4.7993. Awesome. So for our last example, I'm going to show you how to handle operations that actually involve bar numbers so that you also have a proper understanding of how to deal with these numbers in future problems. Awesome. So for our last problem, we are having an operation using or involving bar numbers. So we're having bar 2.49 plus bar 3.53, and you're supposed to perform this particular operation. So before you do anything, you want to understand how to write this bar number in an expanded form. So bar 2.49 is the same as, and you already know it, is the same as -2, all right, which was the nth value of 10 when you were writing it in standard form, of course, when you were looking at the characteristic and all that, and logarithms of numbers less than 1, of course. So therefore bar 2 is going to be written as -2 plus 0.49. So this here is the expanded format of bar 2.49. It's the same, it's just but -2 plus 0.49, and therefore that should make sense that bar 3.53 will be -3 plus 0.53. All right, so for us to perform this operation, we are going to I'm going to rearrange these numbers in a way or a format that is easy for you to understand. So basically I'm going to have the negative numbers adding themselves, and these numbers, of course, greater than 1, of course, also on their own, also, you know, us performing an operation on them, you know, separately. So I'm going to rearrange this whole operation up here as bar 2, of course, plus 0.49, all right, plus, okay, -3 there, plus 0.53. Of course, there's nothing that I've changed. I just arranged it in a format that then becomes easy for you to understand. So I'm going to add 9 plus 3, and that's going to give me 12. I'll carry 1. So basically 1 plus 4 is going to be 5. 5 plus 5 giving me 10. I'll have 0 here, point, and then carry the 1 on the other side. So I'm going to have 0 plus 0 plus 1, and that's going to give me 1. So I've basically added this right hand side of numbers normally, the normal way I would add decimal, okay? So I haven't complicated anything. And so I'm also going to do the same for the negative numbers on the left hand side. So I'm going to take -2 plus -3, and of course that's going to give me -5, of course, with that addition sign right there, because these are bar numbers. So notice that for me to continue, I have to have this number before before the decimal point as 0, okay? So basically that means that I'm going to perform an operation involving -5 and 1 such that I have 0. So I'm going to have -5 plus 1. All right, I'm going to take -5 plus 1, and when I take -5 plus 1, I'll have -4 plus, of course, -4 plus 0.02. And now this number therefore becomes easy to write in bar format, and if I write it in bar format, I'm just going to have the bar sign and 4 underneath 0.02. Therefore this becomes our answer, bar 4.02. So when you evaluate bar 2.49 plus bar 3.53, what you end up with is bar 4.02. So go through this example on your own and see which area you didn't understand, and maybe you can comment on you can write a comment in the comment section, and then I'll be able to reach back to you and see how you can be helped. So that's it for this particular class. See you in the next one, where we'll be looking at anti logarithms. Thank you and have a good day.